So we need to draw the graph of this polynomial function. So we should have an idea what it looks like. So we should be familiar with these polynomials. So what we want to do is do all the parts that we did before in grade 12 math. So we want intercepts. We want to have a y-intercept, or sorry, the x-intercepts and y-intercepts. So we need to factor this. Okay, so I've got a point, my y-intercept's at 12. I want to factor this. Okay, to factor this, I need to find factors that will work here. So I'm just going to try 1. F of 1, I get 3 minus 12 minus 3 plus 12, that's 0. Okay, so my factors are going to be x minus 1. I'm going to divide to break this into quadratic. Okay, so my quadratic ends up being 3. Oh, I should have factored my 3 out of here. Okay, but I end up with, I'm just going to put the 3 out here. So 3 is going to be x squared minus 3x plus 4. Okay, so when the final factored form of this is going to be 3 bracket x minus 1, x minus, well, that's not factorable, is it? Okay, so it's x squared minus 3x plus 4. Okay, I think that's right. Negative 3, oh sorry, that's going to be negative 12, isn't it? So it's going to be minus 4, which is factorable. Okay, so that's going to be minus 4, x plus 1, x minus 4. Okay, so I've got zeros at negative 1, positive 1, positive 4. Okay, so there's my x intercepts. I'm going to have a y intercept somewhere up here. I know this is going to go kind of in this direction like that, right? Now I want to be a little bit more precise. I want to find the max min points and inflection points. So max min points are generated from my derivatives. So differentiating this, I'm going to get 9x squared minus 24x minus 3. Okay, factoring out my 3's. Okay, so then solving this, I need to solve for when this is equal to 0. Just double checking I've got the right 9, 24, 3, yeah. Okay, so when I want to solve this, I'm going to have to use my quadratic formula here. So 8 plus minus 64 minus 4 times 3 times negative 1. Okay, so that looks like it's going to be 76. Okay, so I end up with 8 plus minus square root 76 over 6, which I'll simplify to 4 plus minus divide by 4. That's going to be 19 over 3. Okay, so working out those values then, they're going to be somewhere in here. Okay, so I'm going to have a max 4 minus root 19 is going to be somewhere right about there, and 4 plus root 19, that's going to be about that's 4, so somewhere in here, I would guess. Okay, so I'm just going to draw that into my slope charts. So 4 minus root 19 over 3 and 4 plus root 19 over 3. Those are going to be where I have slopes of 0. Testing my slopes, I know it's going to go up, down through there, like that. Okay, so I'm going to have my max somewhere around here, my min somewhere around here. With these awkward values, I'm not going to really expect you to find the y coordinates, so I'm just going to draw them in like that. Okay, So then the last part of this is working out the second derivative and an inflection point if they exist. Okay, the second derivative of this is going to be 6x minus 8. Yeah, I have an inflection point. Make that equal to 0. Factor that first. Okay, so it's x is equal to 0 at 4 over 3. Okay, so 4 over 3 is right about there. Okay, so at 4 over 3, I have a 0, and I know that if I test my concavities, I have negative and positive concavities. So drawing that in, okay, I already kind of know what that looks like. It's going to go up through here. It's going to have a max. It's going to have a 0 through here. It's going to have a concavity change here. Okay, there's my min. It's going to go through my 0 again there. Okay, so there's my graph of my polynomial. And those are the parts that I'm looking for. All right.